Okay, today we're going to be talking about the derivatives of 6 trig functions. And the great thing about this lesson is that nothing that we're going to do today is actually new information, although there are 6 things that you do have to memorize. But you'll see that it is just really an extension of the product rule and the quotient rule and whatnot. So let's just jump in. The derivative of the sine is cosine. Derivative of cosine is negative sine, and so on and so forth. I do want to draw your attention to one very easy way to remember some of these derivatives. The derivatives of all of the functions that start with the letter c. So that would be your cosine, and that would be your cosecant, and that would be your cotangent. All of these have a negative built into the derivative. So the derivative of cosine, which starts with a c, is negative sine. The derivative of cotangent, which also starts with a c, is negative cosecant squared. And the derivative of the cosecant is negative cosecant cotangent. So let's use this information and let's see if we can do problems 1a and b. Okay, example 1a says find the derivative of y equals x squared times sine x. So this is just a basic derivative using the product rule. So we'll say y prime is equal to the first function, x squared, times the derivative of sine, which is cosine of x, plus the second function, which is sine of x, times the derivative of x squared, which is just 2x. And that's about as far as you can go with this particular derivative. So the first one is just a real simple product rule. Now the second one is going to require us to use the quotient rule. So let's go ahead and see if we can use the quotient rule. So we're going to start with taking the bottom function. So we'll call this u prime. It's equal to the bottom function, which is 1 minus sine of x, times the derivative of the top, or the derivative of cosine, according to the table, is negative sine of x, minus the top function, which is cosine of x, times the derivative of the bottom. Well, the derivative of 1 is just gone, and the derivative of sine, actually what you want to do is you want to cover up any coefficients or negative signs and just focus on taking the derivative of just the function itself, and then any coefficient or sign in front of that function just goes along for the ride. So if you want to take the derivative of sine, you go over here to your table and you say that's cosine. But there's a negative in front of it, so negative cosine of x. All of this is over the bottom function squared. So 1 minus sine x squared. Now let's go ahead and simplify this a bit. If we distribute, we're going to get negative sine of x. Negative sine times negative sine is sine squared. Negative cosine times negative cosine is positive cosine squared. And all of this is still over the denominator squared. Now, hopefully our eyes are drawn to this trig identity that we learned in trigonometry or pre-cal. Sine squared plus cosine squared is equal to 1. So this becomes 1 minus sine x on the top and 1 minus sine x all squared on the bottom. Now introduces one of the main reasons why I never want you to FOIL the denominator when you're using the quotient rule, because if you FOIL it, you may not recognize that something on the top cancels with something on the bottom, leaving us with 1 over 1 minus sine of x. And you want to get in the habit of fully simplifying your answers. Okay, the second example is a very easy example of simple harmonic motion. Basically, you have a spring here that is pushed down 5 units below its rest position, so that when you release it, it just goes up and down and up and down. And so in order to figure out the position of this spring at any time, you will use this formula. S of t is equal to 5 cosine of t. What are its velocity and acceleration at time t? Well, this should not take us very long because you have your position function, 5 cosine of t, and the velocity is just the derivative of the position. So according to our table, the derivative of cosine is negative sine, so negative 5 sine t. Now the acceleration is the derivative of the velocity, which is also the second derivative of the position. That's going to give us negative 5 cosine of t. So here's your position, here's your velocity, here's your acceleration. Okay, next we have a very complex derivative that we need to be able to take, and that is y equals 3 parentheses 1 minus sine x over 2 cosine of x. Now, there are two routes that you could actually take in order to do this problem. You could use the quotient rule. If you do that, it's going to be a long and tedious process, and you're going to have to be very careful with all of your math. That is an option, and you could do it that way. However, there is a quicker way to do this, and so I'm going to illustrate that for you now. Let's say you would distribute the 3 in here to the 1 minus sine of x. So you get 3 minus 3 sine, actually let me write that a little bit better, sine of x over 2 cosine of x. Now we've seen this before a few times in this class. If you separate this into two fractions, you eliminate the need to use the quotient rule. So watch, 3 over 2. So to give ourselves a little bit of space here, 3 over 2. And the cosine of x is on the bottom. So 3 over 2 cosine x minus 3 sine x over 2 cosine x. All right, so let's rewrite this to be 3 secant of x over 2, and then minus 3 over 2 tangent of x. Now, we have not taken the derivative yet, okay? All we have done is split this up into two fractions, and we have simplified the fractions. So that is, all of that is just rewriting the function y. Now we're going to take the derivative. So y prime is equal to, the coefficient goes along for the ride, and then we remember from the top that secant of x derivative is secant x tangent x. And then minus 3 halves again. The derivative of tangent is secant squared x. And so now from here, we want to try to get everything in terms of sines and cosines. So 3 over 2. Secant is 1 over cosine of x. Tangent is sine x over cosine x. Minus 3 over 2 times 1 over cosine squared x. So now we notice that we have a common denominator between these two fractions. So 3 times 1 times sine is 3 sine x minus 3 over 2 cosine squared x. All right, so now all we have to do is a couple little nifty things. We've already taken the derivative. So what we'll do is we'll factor out a 3 on the top, and that's going to leave us with a sine x minus 1. And on the bottom, we're going to change cosine squared into 1 minus sine squared, which is a trig identity from pre-calc. We do that because we can now factor 1 minus sine squared. It is a difference of 2 squares. And this should actually be 2, now that I see. Made a little mistake. So we're going to have 3 times sine of x minus 1 over 2, and then 1 plus sine, and 1 minus sine x. All right, now we recognize that sine of x minus 1 and 1 minus sine of x almost cancel out, except they should leave a negative 1 because they are opposites of each other. So your final answer is going to be negative 3 over 2 parentheses 1 plus sine of x. And that is the most simplified form that you can possibly get this derivative in. Why is it important to go through all of these steps of simplification? Because on an AP exam, this answer may or may not be one of the choices for a multiple choice question. This answer may or may not be one of the choices for multiple choice. So you have to be able to go through all these little algebra steps and get it fully simplified so that you can make the right choice. Okay, so now we're going to do part B, and part B should not be as complicated as part A. We basically have the product rule used twice here. So let's go ahead and do that. So y prime is equal to the first function, 2x, times the derivative of sine, which is cosine of x, plus the second function, sine of x, times the derivative of 2x, which is just 2. Now the product rule is already done for this one, so let's go ahead and do the product rule for this term. So you have the first function, x squared, times the derivative of cosine, which is negative sine of x, plus the second, cosine of x, times the derivative of the first, which is 2x. So let's see what we have here. We have like terms. So we have 2x cosine x and 2x cosine x. So that is going to end up giving us 4x cosine x. And then we have plus 2 sine of x minus x squared sine of x. And that is about as far as we can simplify this problem. All right, example 4 is indeed a challenge with 4 exclamation points. So this is going to be take a little bit of our time. We have a graph here. This is the equation of the graph. I copied this out of the textbook, so these are the answers to parts A and B. You have a red tangent line here, another red tangent line at point Q, one at point P. We know the point P. So for part A, we want to find the equation for the line that is tangent to the curve at point P. Well, the good news is we already know the point, pi over 4 comma 4. We need the slope of this line. Then we can use our point slope formula to write the equation of this line. So let's see if we can take the derivative of y. So y prime is equal to, the derivative of 1 is 0. The derivative of cosecant is negative cosecant cotangent. So negative root 2 cosecant cotangent of x. And then the derivative of cotangent is simply negative cosecant squared of x. So the derivative is quite easy. Now we need to take pi over 4, the x coordinate of this point, and plug it in. So we're going to write negative root 2 cosecant of pi over 4, which is 45 degrees, cotangent of pi over 4 minus cosecant of pi over 4 squared. All right, so let's go ahead and see if we can figure out what all of these things are. I do not teach memorizing the unit circle. All right, the best way to figure out trig functions is simply to memorize 2 triangles. One would be your 30, 60, 90, and the other would be your 45, 45, 90 triangle. And certainly you also must remember so, ka, toa. That's very important. If you remember this and the 30, 60, 90 triangle and the 45, 45, 90 triangle and the sides related to those, you should be able to find any trig expression for any angle. So this is going to be a 45, 45, 90 triangle, which is going to make the sides 1, 1, and root 2. So cosecant is the reciprocal of the sine, so that's going to be hypotenuse over opposite. So we have this negative root 2, that's a coefficient, and then the cosecant of pi over 4 is root 2 over 1. Cotangent of pi over 4 is the reciprocal of the tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So that's just going to be times 1. And then minus cosecant of pi over 4, we already established was root 2. So we want to square that. So let's see what we get. Negative root 2 times negative root 2 is a negative 2. And then we have root 2 squared. Well, the square root and the squaring get rid of each other and leave you just with 2. So this is our slope, m. So let's go ahead and write our equation for the tangent line. So y minus the y-coordinate of point P, which is 4, times the slope, -4, times x minus the x-coordinate of point P, which is pi over 4. And even though the book solves it for y, most problems it is sufficient if you leave it in point-slope form. Right, part B is indeed the challenge. We have to find the equation of this tangent line that goes through point Q. Well, the good news, we know the slope. We know the slope is 0 because it's a horizontal line, but we don't know point Q. We don't know the x-coordinate or the y, and that's going to be the challenge. So we've got to take this derivative. We've got to set this derivative equal to 0 to figure out the x-coordinate where the slope is 0 on this strange looking curve. Now, in order to do this, we're going to do the same thing that we did in example 3. We're going to change things into sines and cosines, so let's go ahead and do that. -√2 cosecant is going to be 1 over sine of x, and cotangent is cosine of x over sine of x, minus cosecant squared, which is 1 over sine squared. So we end up getting on the top -√2 times cosine of x minus 1 over the common denominator of sine squared. That is our derivative rewritten. Now we need to take that derivative and we need to set it equal to 0. So I'm going to rewrite this a little bit more, and let's see if this step makes sense to you. I'm going to rewrite this as 1 over sine squared times -√2 cosine of x minus 1. I'm going to do that because now I'm going to call that cosecant squared. All of this is just a little bit of algebra. All right, cosecant squared and times this. Set this equal to 0, and we have two possible solutions. The first is cosecant squared equals 0, and the second is -√2 cosine of x minus 1 equals 0. Now here, this does not give us any solutions. And that is because if you go and refresh yourself on what the cosecant graph looks like, it never actually equals 0. So this one is a no solution one. Here, we can add 1 to both sides, divide by -√2, and we get a cosine of x is equal to 1 over √2 negative, but I'm just going to move the negative there. So now our goal is to figure out what angle or angles have a cosine of -1 over √2. Well, we can use the unit circle again, the trig reference triangles. And so we notice that the cosine is negative in quadrants 2 and 3. So in quadrants 2 and 3, cosine is negative. So we're going to make a reference triangle in quadrant 2. And we're going to do it in quadrant 2 because quadrant 3 is going to be too big. We're looking for the solution that's between 2 and 3. And it's going to end up being the one in quadrant 2. So this is going to be your 45, excuse me, your 90. There's your 45. So adjacent, cosine is adjacent over hypotenuse. And this is going to be 1. So this is going to give us an angle of 135 or 3 pi over 4. All right, so 3 pi over 4 is our solution. That's our x-coordinate. Now, take 3 pi over 4, and I want you to do this on your own for the sake of time for this video. If you plug 3 pi over 4 into this function right here, I'm going to put it in a box, then you will get the matching y value. And when you do, you're going to end up getting y to be equal to 2. Now, from this point, we need to write the equation of this horizontal line. Well, you've got your answer. Y equals 2. Because if the point on this curve is 3 pi over 4, comma 2, and we know it's 3 pi over 4 because pi, if we round it to be 3, 3 times 3 is 9 divided by 4 is 2.25, so that is the right solution. So if this is the point 3 pi over 4 comma 2, then the horizontal line that goes through this point is simply y equals 2. So that is the answer to part B.